Welcome back. In this lesson, we're going to look at the groundwater and the supply of groundwater and the use of groundwater. Everybody wants groundwater. They want to drink it. They want to take a bath occasionally. They want to feed their animals or water their animals. And so groundwater is precious, and most wars, believe it or not, have been fought over water. Water is the resource that people will fight over, and when you don't have it, you'll do whatever it takes to get it. So taking care of it is really important, and knowing how to take care of your own property and then also taking care of your property so that you're not hurting other people is something worth learning. One of the beauties of how the earth is designed is got to be that the ground actually cleans the water. So water can be polluted in the air. It can be polluted in the streams, and as water percolates down through the stone, the aerated stone, and finds itself into the water table, especially if it's at any way deep, much of even microbes has been cleaned. And so groundwater often is very, very clean. Now, it is possible that you can spoil a well or spoil your neighbor's well, but normally groundwater is very potable, which means it's drinkable. You can drink water that you draw out of a well. So let's look how wells work for a second. A regular well is just a pipe or a hole in the ground. Long time ago, it was just simply a crack in between rocks that you were able to put a pitcher or a bucket down into. If you were to dig a well, sometimes, depending on where you dig, you don't have to dig very far down into the ground to where all of the rock is got water in it, and then the water kind of seeps into it. In fact, there's lots of times just digging for a basement for your house, you're going to have groundwater that'll seep through the basement walls and into your cellar. So that's a very common event. So you don't have to go real far down. Now, if you live on the top of a mountain, yes, you probably do have to drill pretty far to get to the water table, but usually it's rather close. And so when you dig down, you want to go down into that layer of rock that's saturated with water. Okay, that saturated place is called an aquifer. Aqua is from the word water, like aqua in Spanish is water. So if you go into the water table, that's called an aquifer. Normally an aquifer is sitting in sediment. So it's in between the pores of rocks, or it's in between the grains of sand or something like that. Also, normally an aquifer is sitting on some kind of an impermeable substrate, some kind of a foundation stone that the water can't get any farther down. So if you are, say, in limestones, which are porous, the water could seep through cracks and in the limestone itself, and almost like a sponge. And then as it reaches, say, sandstone, which is water can't go through, it sits just like the bottom of a swimming pool, and the water sits on top of it. So that's called an aquifer or a water table. So if you have wells in that water, okay, it is possible to feed an entire neighborhood depending upon how much water it is, if you do not take too much water out. Because what's actually happening, as water comes through that pipe, it travels very easily and very fast. As water seeps through the rocks, it goes much slower. So if you essentially, almost like using a straw in a glass of water, if you drink very quickly through the straw and all the water goes into the straw, then as the water is creeping through, say, the crushed ice, it's slower. And sometimes you have to take a drink and then wait a minute for it to reestablish, and then you can take another drink. I've done that. And that's called the cone of depression. The cone of depression is the slower rate of water raising back up to a level. So if you drain it by pumping it too heavily, and then you, especially if you have a deep well, you may actually run your neighbor's wells dry. So if you look at the picture here, Mr. Greedy's second house has a long pipe, and it's deep into the water table. And if as it is sucking a lot of water, then what's happening is it drops the water table, because that water is now wherever that well sent it, and now the pipes that the neighbors are putting down into the ground don't go far enough to reach the water. And the cone of depression is that essentially a triangle or a V shape where the water is going much slower through the rocks than it is through the pipe, and you end up with a cone. Now, cool is an artesian well. If you've ever seen an artesian well, you'll remember it, because the water is not being pumped at all. The water is deep below the ground, but somehow the water is under pressure. If the water is under pressure and you pipe it, it would just be like popping a balloon, and that air that's under pressure will find its way out of the split in the balloon, and it'll pop. Same thing with this. If you have a high pressure water and then you put a pipe down into that water, the water will instantly squirt out of the top of that well. The more pressure, the bigger the squirt. You could have a dripping fountain, or you could have a huge geyser of a fountain, depending upon the amount of pressure. The way that water is under pressure is if it has a basement and a roof. So if it has a non-permeable floor, like a floor of a swimming pool, but it also has a top to it that it can't get out of. So it's trapped in between two layers of impermeable rock. Then if somehow the water table is up above wherever the roof is, then you put a pipe there, it will spurt. I'll see if I can explain it. Do you see that you have these aqualudes? An aqualude simply means it's impermeable. It can't go any further. Okay, so you've got a impermeable layer on the bottom. The water simply just runs down that rock and sits on top of it. Then you have an impermeable layer as a roof, but it's not flat. It's curved. So you see the recharge area, that's where it rains and new water fills that essentially cavity. And since the water level is very high, the water table is very high, that means everything below it has water in it. Well, if you were to sink a well equal to the water level, then the water would rise up to the top of the well. If you sink a well where it's below the water table, then that water is under pressure and it will spurt, and that's called an artesian well. Now, some of the threats would be overpumping. If you overuse the water, then faster than it can recharge, and remember, recharge means it rains on the rocks and percolates down through the ground and reestablishes the water table. A well doesn't go forever. You can easily run a well dry, and especially if you're just accessing it when you need it, no big deal. But if you have somehow a pump system to where you're not even paying attention to it and it's pumping all the time and you aren't looking, you could easily pump the groundwater out without even thinking it. Sometimes if you have pumps for livestock and things like that, it's very possible to essentially drain all of the water out of the water table. So overuse is one. Subsidence. So let's imagine that the ground is a sponge and it's got water in it. That sponge is nice and high. When that sponge dries out and loses all of its water, it shrinks down to a lower size. Exactly the same thing happens with the ground. If you have a ground level because you have water in that ground, then it's at a certain level. But if you pump all the water, which is below ground, out of the ground, then all of the dirt and rocks which were kept up by that water is now sinking, and you have subsidence. And that happens a lot of times in agricultural areas in the West, say the mid-valley of California, where they grow so many vegetables because of the weather, but there's not a lot of rain. And so they're draining their well water by doing lots and lots of irrigation for their farms. You can also pollute groundwater. If you were to have, say, a situation where you've got a septic tank that's faulty and it's essentially leaching microorganisms and all kinds of sewer into the groundwater, then it won't bother your well usually, but it will normally bother anybody's wells that are downhill from you. And so that, and remember, if you're on the top of a hill, your well has to be deeper in order to do that. And so, yes, you can easily contaminate. And sometimes you can contaminate not knowing it. Fertilizers at a farm, that will contaminate water. If you have storage tanks, lots of mines would do this. They have storage tanks full of fuels and things like that, and it seeps. There was a storage tank leak a few years ago, got into the Kanawha River, and hundreds of thousands of people had their water poisoned. Okay, so that's a big, big, big deal. Another problem, I guess, I don't live near the beach. I wish I did, but I don't live near the beach. If you have water that has salt in it, say an ocean, and then you have water that's from the land that its sources from rainwater, that's fresh water. Anywhere that fresh water meets with salt water, that's called brackish water, and that dispersion zone the salt water can poison the fresh water. So if you had a well, if you lived in a town next to the ocean, your well could be contaminated by the salt water that's seeping in through the ocean. And so that's another thing that has to be considered if you're in that area. And lastly, radon. I don't want to give you nightmares, but radon gas is it's just a gas that's deep, deep in the ground, and then anywhere there's cracks in the ground will find its way up. It'll bubble its way to the surface. And radon is radioactive. In fact, that's the reason it's called radon. It is breaking apart, and it's releasing energy, and that energy can be damaging to any living thing that's in its way. And there really is very little to do with it. I know when you get a loan to build a house, one of the tests that has to be done is you have to test for radon gas. Do you live in a place that has so many cracks in the ground that this radon gas is able to percolate up through it more so that you have a higher level of radon than everybody else does? Then possibly you won't even get your bank loan. So that's another one. And it does cause cancer eventually just from exposure, and you don't even see it. You can't detect that there's radon there. There are detectors that you can use to see if you have radon coming out of your basement or out of the pipes, but sorry, it's a scary place we live in.